1 second. Because palindromes are pretty straightforward. So B is an input. Yes, B is an input. It's not a blank. Okay, so here's the thing. Checks if the string is reversed or no. I think that's probably what it is, if the string's reversed or not. But before we go through anything, let me just step through this. Let's just go with anything, okay? A, B, 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 A, something like that, okay? I don't know. Let's step, step, step. You see how you have a bunch of boxes on the side? That's basically how you know that those are the blanks. Anything else is not a blank. And I don't know why my test is failing because I don't remember what the correct string was supposed to be. You can try ABA. Okay, sure. Let's try ABA. So cool thing is if you don't like having to do multiple different input tests, you can go over here and you could do multi-run. This is actually what saves you a lot of time. So I can do ABA, right? I can do A, B, 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 A, A, something like that. I don't know. Then I can do A, B, 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 A, B, A, whatever. You know, like you just keep adding multiple different example strings, right? A, B, A, B, A, B, right? Something like that. And then what you can do is you could do multi-run. And what multi-run will do is it'll run through all the possible scenarios so you don't have to manually step through them. And this is a good way for catching edge cases, right? This is a good way for catching edge cases if you mess up or whatever. So let me now run through this. Load inputs, run inputs. So let's run this. So the reject state means that all of them failed. And obviously they failed because I have no idea what I'm doing, which is okay. Sometimes it's okay. It's okay
to be for them to learn. That's nice.
Let me go to File. Let's go to Open. Let's go to Palindrome. So let's go to the previous file, which is student submissions. Let's go to Jason's Palindrome. Click Open. Yep, standard Turing machine. Is it standard or is it the Turing machine with building blocks? I think it's standard. I'm going to close this one. I'm going to make this one, and then I'll make it a little bit bigger. I think that's big enough. Okay, so we have this Turing machine over here, and we want to see if a string is a palindrome. Okay, so let's go into input, step. Let's give it a palindrome string. It's checking for all strings that are A and B, right? So A, B, B, A. And if I swap this, yeah, this should be a palindrome. Okay, let's click OK. Let's step. Okay, it failed. Why did it fail?
What'd you have, ABBA?
Yeah, I had ABBA. If you swap that, that should be a palindrome. I don't remember what's happening.
It is, yeah.
Ray, a suggestion. Maybe you had a capital B to denote a beginning and ending of your string, or maybe the end of the string.
That's possible. So let's just reset.
Play around with it, you know, with your partner.
But this is kind of what it is. Like the moment you start learning how to actually create states, create your arrow diagrams, once you get past. So the thing is that a lot of people that don't, like, this is why I emphasize learning JFlap in the beginning of the course, because creating these states, moving from state to another isn't really that difficult. Creating a Turing machine from a diagram or an example from the textbook isn't difficult. It's actually understanding what's happening and also running all these test cases. Running all these test cases is probably going to spend 90% of your time, basically. So the sooner you learn how to get comfortable with JFlap, the better time you're going to have running through multiple inputs, which is like 90% of your time. So let's say beginning of the string, A, B, B, A, and end of the string, okay? Maybe that might help, right? So let's step, okay. It reaches, it somehow passes, don't know why, but okay. Let's do another test. Maybe you need to have an indication that you reach the end of this string, what he mentioned. So 1 second. A, B, B, A, and then a capital B at the end to denote this is the end of the string. Okay. Step, 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 step. Yep, so that's basically what you need. And that green indicator means that you have reached a success state. So this string is in fact a palindrome, right? There you go, yeah. Iram, you're correct. That's basically what it is. It needs to know what the end of the string is, right? That's basically what it is. Can you try one that isn't? Absolutely. We can do multi-input. So we're gonna do over here, we're gonna go into, let me close this. Well, you can have it open. It doesn't really matter. I'm going to go into multiple run. And what I'm going to do is I'm going to put a bunch of palindromes here now. So I'm going to put A, B, B, A. I'm going to put A, B, B, A, B, B, A, right? And then we're going to put A, B, 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 A,
That'll do it.
A, B, B, A, B, B, A, right? Yeah, that's a palindrome. And then finally, some that are not palindromes, right? So let's make this bigger. And then let's go with A, B, A, B, A, B, right? A, B, 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 A, something like that. And then we can run through all of them, right? So one second. Now, I keep forgetting you have to have the end of line indicator, right? To let them know that this is the end of the line or end of the string. Let me just add that quickly. And then finally go over here. Okay, so that should take most care of it. Okay, so there's some questions in the chat. Sorry, let me just go through that quickly. Don't forget the B at the end. Yeah, I got it. No problem. And then finally, let's run the inputs. And as you can see, the ones at the top, let me make this bigger. The ones at the top, the ones that I knew were palindromes were obviously accepted, and the ones that weren't were rejected. And so this is something that you're going to, I'm telling you right now, this multi-input thing that I'm doing here, this is going to be 90% of your time. You're going to be sanity checking to make sure that you're not missing anything, especially with PDAs, which you're not doing obviously for the report, but it might be good to go through because, again, if a problem is solvable on a PDA, it's solvable on a Turing machine. If it's solvable on an FA, it's solvable on a Turing machine, but not the other way around. And so this is another example. You want me to try any other strings?
Can you try like the simple ones like A and then B? Like those are two separate inputs.
Okay, A, B, and then at the end like this. This will
No,
fail.
like only one letter. Only one letter.
Oh, the answer is yes then.
I think by default it should be, but I don't know actually. See, that's an edge case. You would want it to take, there you go. You want to take that into account. Let's see what happens. Let's run this. Let's run these inputs, and it's accepted. Yeah, because by default, if you flip the string, it's what it is, right?
Yeah.
So that's an accept state. So that's one way of looking at it. Let me look at another problem. So let me close this multi-run, close this. Let me run into open another file. File, open. Let me leave this on the side. Let me go into student submissions. So these are just problems we did throughout the semester. These aren't actual like final submissions for the report, but it's just to give you an example of what to expect. We have Bujar, Mr. Albania over here. What was his problem? I wonder.
Oh.
Yep, Mr. Albania. I love that name.
Now I remember, yeah.
Whenever I'd call him that, he kind
The
of get like
nicknames I gave them that stick in my head, yeah. I got that from Professor Gertner. He used to give everybody names, so I started doing it.
Okay, I have no idea. Okay, if I put in a 1, it's going to write a blank and it's going to move to the right. If it sees another 1, it's going to write a 1 and then move to the right. And then if it sees a blank, it's going to write a blank and move to the right. And then keep doing this. And then it's going to move to the left. I don't really know what this is doing, but I'm going to experiment with it anyway.
That's why you're going to put a short description of what your program does. That's part of the submission.
For the report, yes, but these were like problems we did in class. Like he had a PNG image of what the problem was, right? I don't think I have it. Anyway, I think maybe this is just to check if your string is even or odd. I don't remember. Let's just step through this. Let's see what happens. It's doing something. I don't know if I could make this bigger. Can I make this bigger? I don't know.
I think you're stuck with that.
It's doing something, right? It's moving numbers to the side, and then it's basically moving to the left, and it's turning the leftmost one to a blank, and then it keeps moving to the right, and then it finds the rightmost blank, and it adds a 1 over there, I think. And then it keeps moving to the left. And then it keeps doing this. Okay. Okay, it's going to move over here. And then it's going to move over here. And it's going to keep doing this again and again. And it's going to turn this to a blank. And then it's going to go over here. And then once it reaches the leftmost state, it should stop, I think. 1 second. And then it gets to the last state, and then, yep, that's, oh, okay. How do I go back? But yeah, once it goes to the leftmost state, it's going to basically, it basically ends up reaching the success state. Let me just quickly rush through this. I know there's a question in the chat. I'm going to take a look at it, but let me just rush through this. And finally, it looks to the blank, turns right, looks to the 1, success state. Okay. Over here. So is this infinite? No, it's not that it's infinite. What's happening is it looks at the number of 1s we put past the blank, and then what it's doing is it's adding numbers to it. So depending on the...
No, someone sneezed in your chat room.
Oh, I think my brother sneezed.
I thought so. It sounded too live, like, yeah.
So yeah, let me close this. Let's go into multi-input. So let's go to input, let's go to multiple run. And instead of putting A's and B's here, which if we run, this won't even make sense because it's not looking for that. We're gonna put a couple of 1s, right? We're gonna do 1, 1. We're gonna do 1, 1, 1. 1, 1, 1, 1. And basically this is a way of saving you time. So now if I run the inputs, 500 configurations have been generated. Should we continue? Yeah, why not? 500, should we continue? Yeah, why not? And there you go. And everything is accepted, right? So we've all reached the accept state. You might reach the decline state depending on how you do, but depending on, like, if I put 1, 0, 1, I don't think it's accepting. It would not accept this. So let's run the input. Reject. Okay, there you go. So it rejects it. That's pretty straightforward. Anybody have any other questions? Does anybody have any other questions? How we create states. Okay, good question. So this is just like how to run through the input and run through the program, but how to actually like create a Turing machine. So let's go to a particular problem. Let's create so what was the example supposed to do? Basically what it does is it looks at your start state, right? Your initial state, Q0. And what's happening is if it reads a 1, it's going to write a blank and move to the right. And then if it sees another 1, it just continues moving to the right until it reaches the rightmost blank. I think the best explanation for this is if I actually like manually do another manual input. So let's go to step by step and do 1, 1, 1. Okay. So we're at the leftmost blank. I don't know if you can see it. It's like a little red 1. Do you see it? So does anyone see it? I'm sorry if it's small, but copy, input, output, the same input for 1s only. I see. Yeah, so it sees the leftmost 1, right? And then it moves to the right. And it sees, okay, it writes a blank and it moves to the right, and then keeps seeing a 1, so it keeps moving to the right until it hits a blank. And on this blank, it writes a 1, right? It moves 1 past that right and writes a 1, and it keeps doing this multiple times. It keeps going to the left, keeps doing it, and then it goes past the blank, writes a 1, and it goes all the way to the left. It sees that there's a blank over here, and then it goes past the original blank, goes to state 9, where it sees, okay, there's a 1 over here, and if there is a 1, we've reached the success state, right? Does that make sense? I'm kind of rushing through this, but yeah, it shouldn't be all that complex. Depends on your problem. Like if I knew the problem by heart, in and out, then I would be able to like go through it with more depth. But that's an example. Wait, my bad. I think I doubled the input. I think a doubled input will depend. It's like if it's in binary, if it's in unary, then that's what it would probably do, right? So I'm going to see if we can open up one more. So someone had a question about states. Who had that question? Should we go over like making a simple JFlap program?
Yeah, and then click twice to get this, you know, the line between them, so to speak.
Okay, like I think JFlap, I have a tutorial on the course webpage. They don't have to see the entirety of it, but it's 1 second. It's on the 1 second. 1 second.
Mm-hmm.
1 second. So it's on the course webpage. There's a little tutorial here that they can kind of go through it. But if they don't want to go through that, I can rush through this. File, new, let's call it
Hello? I'm good. Oh, I know. Friday, when I went to the hospital, the woman there wanted to give me a lecture, no. I mean, training me for something. She was wait a minute. I'm getting away from my computer.
Okay, so
yes, I'll be there in like 15 minutes.
Does anyone have any questions about PDAs?
I'm gonna probably wait outside.
The training in how to handle.
Is she gonna be in the same?
It ended up being an hour. I thought I was
beginning.
just going in. He was going to give me the medicine name, and I was leaving. No, he kept me for an hour. I'm sorry. Yeah.
So I have my state. I can click on this, right? I can do this to make it bigger. I can use this to select my state and move it around. I can use this to delete my state if I don't want it. So let's create a state, call it Q0. And then I go over to select, and I can right click, and I can set this as my final state or my initial state. I'm going to make this my initial state, right? And I want a PDA that accepts all strings that start with A, and for every A, there must be 2 Bs, right? So what I'm going to do is I have my state Q0, and I'm going to make another state. I'm going to call it Q1, right? And I'm going to say, okay, to go from QA to Q1, if I drag my thing, click on the arrow, and then if you drag this arrow, it's going to give you these 3 options. So you can basically read, pop, which is to pop something off the stack or push something onto the stack, and then push. So with PDAs, remember, you have a read head, and then you have a stack on the side that's keeping track of something. So if I see an A, I want to push a sharp, push a sharp onto the stack, and I'm not popping anything off the stack, right? So if I see an A, I want to push this onto the stack, and I want to go to Q1. And I want to repeat this step for all steps going to QA. So for any other A I see, I want to push a sharp onto the stack. So if I see any A, I want to keep doing this. So far, so good? Does everybody understand what I'm doing?
Yep.
Okay. Then what I'm going to do is I'm going to make another state, and I'm going to call it Q2, and I'm going to say, okay, so for the first B that I encounter, right, for the first B that I encounter, I do nothing. So if I see a B, right, if I see a B, I do nothing, but I move on to this next state. Because this is the first B that I've encountered, right? We can't pop anything off a stack right now because my rule is that for every AIC, there must be 2 Bs. Because remember, PDAs are able to keep count. They're able to keep track of counting. So then if I see another B, right, and if I see another B, I want to pop the sharp off the stack, right? That's basically what I want to do. But actually, we don't want to do it like this, because what happens if I see a third B or a fourth B? We want to do this for every two Bs we see. So what I'm going to do is I'm going to add another state, call it Q4 or Q3, and we'll have another rule let's set. That is that when we go from state Q to Q3, I see another B, I want to pop the sharp off of the stack. So far what happens is, let's say you have a string AA, BB, BB, right? Or ABB, right? You see an A, you put a sharp onto the stack. And then for any other A you see, you would repeat this process. You see a B, do nothing, just move to Q2. You see another B, this is the second B that you've encountered. Pop a sharp off the stack, right? And then what I want to do is, if you encounter another B, let's not do that. If you encounter another B, that's the third B that you've encountered, right? What you want to do is go back to this state, right? If you see a B, do nothing, go to this state. You see a fourth B, pop a sharp off the stack, if that makes any sense, right? That's basically what you're doing. And then, let's see. So if I put in an A, then it's going to put a sharp on the stack. I put another A, there's another sharp on the stack. I put my first B in, right? I do nothing. I see my second B, I pop that off the sharp. My third, my fourth, and so on and so forth, because this is basically varying by 2. So for every 2 you see, you're going to be popping a sharp off the stack. So this makes sense. And then let's make a fourth state. And I'm going to call it, I thought the second operation was pop and the third was push. We'll find out, right? Like, I'm crazy and I'll make mistakes, and that's okay. Let's see. This was what? Read, pop, push. Okay, you're right. So you push a sharp onto the stack, and we're not popping anything because we can't. All right. And we repeat the same process here. Thank you for catching that. Do nothing. And then for this one, we're not popping something off the sharp, we're pushing it onto it. Read. What is this? Pop. Pop. Okay, so yeah, we're going to pop a sharp off the stack. There you go. Okay. Thank you. And then once you do all of this, we're going to say, when I reach and I see nothing, lambda is kind of like JFlap's way of saying empty or nothing. It's kind of like their version of saying, so when you're dealing with PDAs, you don't have blanks, right? The squares that we normally see, you have lambdas, but that's just their notation for it. It's weird, but you'll get used to it. It's just, if I see nothing, that means that I've reached the end of the string, right? And if it passes Q3, meaning that it's popped all the sharps off the stack, right? That's the assumption. And my stack is empty, meaning that we've reached the end of stack marker. We should reach Q4, right? Let me erase that. And I think the end of stack marker, one second. The end of stack marker is specific. I think it's like an EOS or something. If you read, I think it's end of stack EOS, something like that. It's like if you read the end of stack marker or whatever. But you get here, this is Q4. I'm gonna click on this to select, right click. I'm gonna make this my final state. So this is my accept state. And then what I'm gonna do is, let's try running the inputs. So we're gonna go here and we're gonna go to input step with closure, cancel. Let's go to input with step with closure, right? And we're gonna put in a string A, B, B, like okay. And so now we have our first state, right? Z is the empty stack, I think. So let's step. So we see that there's an A, we pop a sharp onto the stack. And then we see that there's a B, we do nothing, we move on. We see that there's another B, right? And we pop that off of the stack. And because our stack is now empty, right? Z is kind of like an indication of the end of the stack marker. Now that we know that our stack is empty, we reach the success state, right? Well, that's pretty easy. Let's do multi-input. So let's go over here. Let me make this bigger, sorry. And let me go into a multi-input. And let's do A, B, B, A, B, 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 A, B, 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 and so on and so forth. I think you get the idea. You'll notice that this doesn't work with strings such as like A, B, A, B, A, B, because I haven't taken that into account. This only accepts certain strings that are A's followed with B's, such that for every A, there must be twice the number of B's. And this is because this is a deterministic PDA. There may be cases where you can use a non-deterministic PDA. And that's interesting because there's going to be cases where it's going to run through all the possible scenarios and it guesses until it reaches the success state. So it's pretty interesting. So let me just do a case where it would fail. Okay, and let's run this. And oh, so the blank, obviously the blank, it would fail it anyway, right? But let's give it more inputs. Now this, for example, should be a correct string, but it won't pass. And the reason why is because in Q3, we don't have any condition where it says, hey, if there's another A that you see, go back to this state 0 or something like that, right? So that's something how you can actually improve it. Where if, let's say I'm in state 3, I've seen my second B and my stack, the sharp hasn't popped off my stack. What happens if I encounter another A? Well, if I encounter another A, I should pop something onto the stack, right? Push something onto the stack, and I should go back to Q0, for example, right? Or Q1. And then if I encounter another B, so on and so forth. So maybe you can actually modify this to make it accept more kinds of strings. But as you'll see, this one will probably fail, even though it is technically correct as you have twice the number of B's for every A. So let's run this again. And as you can see, this one is accepted and this one is rejected. So yeah. Let me see if I can save this file. And I will I'll upload this to the course webpage so that you can take a look at this and mess around with this later. So does anybody have any other questions? I think this concludes it. You can carry on the rest from here.
Okay. All right. Thanks, Ray.
You're going to have to hit the share screen button to get to the lecture notes. They can't see anything.
Oh, so share screen first?
Yep, and then the blue button after that.
Yeah. Okay. And 1 second. Lecture 21. They can see me now?
Yeah, they can see you.
All right, very good. Ray, you still there?
Yeah, someone has a question.
Go
It
ahead.
is how will we have a final exam with the project?
What does that mean?
Will you have a report on the PDAs and will you also have a final exam?
There's no PDAs on the report.
No,
There's
no.
only a Turing machine.
No, but they're saying, will there be a final exam alongside a report with Turing machines?
Oh, yeah, we can discuss Turing machines on the final. since you're going to be working on a JFlap example. Yeah, you would feel disappointed if we didn't have another Turing machine on the exam. Yeah, that's okay. Does that make you happier or not? All right, they're not answering. All right. So we were talking about, oh my God, do we have that much time? All right, we got 20 minutes. We were talking about undecidability and the halting problem. I don't think I'm going to go through it again. You're going to have to study this. This is not easy stuff to digest. All right. One second. All right. So this is where we were. Anvina, you were at, well, I guess you're there. All right. So we were looking at the post-correspondence problem. Somebody please tell me what this is. Hello? Are you there?
Yeah.
Okay.
I was asking if you could make the same sequence with only using sections of part A in list A, and you could only use it in the segments in list B. You could make the same sequence.
Oh, okay. Very good. Yeah. Is there a permutation, sort of a sequence of integers, such that if you build, think of it as I like to think of it as two trucks that can come to your house. And those are like blocks that you play with. I used to have a cousin who'd come. I'd have a lot of homework from high school, and I was trying to get my homework done, but he wanted to play, so here we are with blocks, wooden blocks that you see on the lower right portion of the screen. And can we find blocks that sort of, when we put them together, you have the same string on the top as you have on the bottom, even though the strings, the blocks are coming from different columns. Okay, so yeah, so if you tell me 3, then I've got 1 0 on top and 0 on the bottom. If you say 1 next, I have 1 on top, so it's 0 1, and so on.